This is the Smallrig 4974 VB99 Pro mini V-mount battery. I was sent this to review for free. If you wanted to purchase it, it would cost you about $250 MSRP. They haven't paid me for my review, and my opinions remain my own. Alright, so the packaging is almost exclusively paper cardboard type products. We get a couple of different documentation cards. It comes with a cable with a pretty nice little cable retention strap here, which has, instead of Velcro, kind of the flexible plug type thing. I think Velcro is slightly easier to reconnect, but this guy doesn't stick to other things. And it is a SmallRig branded, so it has SmallRig at the ends, USB C to C cable. The markings on the other end of the cable actually say 240 watts, so it looks like it's a pretty capable USB C to C cable. So this is a mini DTap on the side here and V-mount battery, and it also has on the top a little rubber cover covering several ports. And so we have a USB-A port that will do quick charge out. We also have a USB-C port for going out and a USB-C port that does both in or out. And there's two DC voltage plugs. There's a 12 volt out and an 8 volt out plug. The 12 volt out is a 5.5 millimeter outside with a 2.5 inner side, and the 8 volt is the 5.5 outside and the 2.1 on the inside. Now on the front there is an OLED screen, and there is this little tape that looks like it's supposed to pull a plastic cover off, but there's no plastic cover that the tape is pulling off, at least not that the tape lifted. So either the plastic cover's on there super well, or it didn't actually come with a plastic cover. Now this guy has an OLED screen, and it has a circular charge indicator, and it says from the factory it's at 72% charged. Now you might be wondering, hey, what's the difference between the Pro model and the regular V99 model? And there's not a lot of difference physically. This guy here is just a millimeter or two taller this way, and that's probably more for control electronics. The displays are a little different. This display here has kind of a percentage indicator, whereas this guy has this percent with the circle around it. So that's probably the easiest way to tell them apart, just by looking at the front display, is does it have the circular indicator or does it have to have the percentage mark. Also, the ports are different. So on this guy here we have two USB-C ports, and with this guy here there's only a single USB-C port that's an in-out port, and then the USB-A and the two DC voltages. So really the major difference between these two is the additional USB-C output port. Now looking at the specs, I'll have to compare a little closer, but I believe the actual capacity of the batteries and all of the input-output amperages are basically the same. Both of them claim in and out at 100 watts on USB-C. My suspicion here is the main difference is the electronics. I've done a review on this guy already, so you can find a link to that as well. So this guy is all aluminum construction for the case. So this black part on the back and the green part here are both made out of aluminum. The front panel, I believe, is plastic, and the actual screen is just that little rectangle there behind that plastic. Now the non-Pro model is all plastic for the entire case. The size of the screen, the little rectangle there, is about the same, but there's plastic down here, whereas this guy kind of has that clear plastic going all the way down. So that's another clear visual difference between the regular and the Pro model. So this is the USB-C 1 port. It supports power delivery, Apple BC 1.2, Quick Charge 2, and Quick Charge 3. Alright, so this is USB-C 2, the output-only USB-C port, and it looks like it supports all the major standards: power delivery, quick charge 2 and 3, Apple BC. It doesn't support some of the company-specific standards. Alright, this guy was at 34% charged. I've plugged it into a 100-watt USB-C power delivery power supply. So it's negotiated the 20-volt rate. The current is currently ramping up. It looks like it's maxing out at about 92 watts. And so we are going to charge this guy up, and I'm going to use a time-lapse camera here to watch this, and we'll see if it maintains that, near 100 watt rate through at least until the 80% charged level, or if it starts tapering off, maybe due to thermal regulation or anything like that. It's been charging for 20 minutes, and we're still at the 91, 92 watt rate. It has ramped down, and it's charging at 61.5 watts right now. So it's not able to maintain a 100 watt charging rate continuously. Now, we are also at 85%, so it might be that the cells are just getting charged enough that they're tapering off their demand. Okay, I've charged this guy up from about 35% to 85% over the course of about 35 minutes. Most of that was at a 90 watt rate, and it's tapered down here down to more of a 62 watt rate. It is slightly warm to the touch. Probably the warmest part is the back here, this aluminum back plate. So the thermal camera says that guy is at 103 Fahrenheit at the hot spot. So, it is definitely dissipating some heat, but it's certainly very manageable and not at all worrying the amount of heat that it's generating. You can kind of see it looks like individual cells. It looks like there might be 3 cells on top there. In the rear, you can't really see those cells showing through because it's an aluminum backplate, so it kind of spreads the heat around. Alright, this guy's at 100%. It's been at 100% for a while. It's still drawing 1.7 watts, but I think that's just to do the display in the screen. When I turn the screen off, it goes down to 0.5 watts. So it is fully charged. So the USB-A port is delivering 3 amps with absolutely no voltage sag. It's at 5.0 volts, so we're getting 15.3 watts out of here. Now the front panel display is basically saying USB-A port is delivering 12.1 watts. This meter says it's delivering 15 watts. So the front panel display says that it's providing 5.4 volts. This meter says 5.0 volts. So the voltage here is a little overestimated, and the watts, I think, are a little underestimated. It doesn't show me the amp, so I don't know exactly what's going on there. It is calculating a runtime of 5 hours and 31 minutes here. And so if we're drawing 15 watts, 5 hours at 15 watts is less than the 99 watt hour rated capacity, but it is going through the conversion inefficiencies of that battery to USB circuit. So we're going to draw it all the way down, and then we'll see how many watt hours it takes to charge it back up. And that will give us a lower and an upper bound estimate on the battery capacity. Okay, this thing says 0% left, and it's trying to turn on the USB port, but then the USB port turns off and flips on and off. So basically it is fully discharged. So it has delivered 79 watt hours out of that USB-C port with the inefficiencies of the voltage conversion from the actual battery voltage down to the output on the USB-C port. So that's basically 80 watt hours delivered out of a 99 watt hour battery with conversion inefficiencies, losses. That seems very reasonable. And we're going to charge that guy back up, and we will see how many watt hours it takes to charge up. It should be a little bit north of 99. Now I plugged this guy in, and it only went up to the 5 volt level at 2 amps, and so it is drawing 10 watts, which is not a lot of power. The meter here says 0%. It has a little green lightning bolt to indicate it's being charged, and it says USB-C1 4.8 volts with a down arrow, which I'm assuming means in. And so if I double tap the battery button, it goes to watts, and it shows 10.4 watts coming in. So I thought maybe my meter was limiting this guy, but plugging in directly to this cable, it is only doing 4.8 volts in. That might be because the percentage charge is so low. It might be kind of, charging it very slowly, and once it gets up a couple of percentage points and says, okay, I'm doing okay, my battery cells are all right, it might go to a higher power level. Alright, the third time I plugged this guy in, it negotiated up to the 20 volt level. So now it's doing 19.8 volts. It's 4.6 amps, and we are drawing basically 92 to 93 watts coming into here. On the display, we still have that green charging lightning bolt, although now it's up to 1% charged. C1 says 19.5 volts. If I double tap the battery button, it changes over to 94 watts coming in. And the battery voltage here is 13.6 volts. So that was about 11 volts when I first looked at it. So it looks like it's getting enough power to kind of bring the voltage of the battery, internal battery, up. Alright, so we are at 54% charged, and yet the power going in is only 32 watts. So we can provide, almost 100 watts out of this cable. So this guy is throttling back a bit, even though it's not up at 80%. So it looks like it's not able to maintain the 100 watt charging rate continuously for the entire charge of from 0 to, 80% or 100%. Okay, this guy's 100% charged, and it took 117 watt hours to do so. I've plugged into the USB-C 2 port, and I'm powering my little telescope here. It is drawing 9 volts. It's only doing about 5 watts right now. According to the front panel, it'll be able to drive this guy for 14 hours and 31 minutes. So one nice feature of the port cover here on the battery, there's a little nub, a little rubber nub, and you might notice there's a little notch in the case up here. So you can actually take that nub and place it into the notch, and that will hold the battery cover out of the way so it doesn't flop down. It just sits right there. Alright, I've plugged this into a USB-C power delivery cable that can do up to 100 watts. It's drawing 92.5 watts out at the 20 volt level. I've reset the watt hour counter. We'll see how many watt hours it takes to charge it back up. Alright, this guy here is at 83%, and the power draw is tapered down here. It's only drawing 60 watts right now. It feels just barely warm to the touch, so it might be thermally regulating, or it might just be that the cells are hitting kind of that area of the charge curve where they start tapering off their demand because they're at 80%. Alright, so this guy says it's 100% charged, but it's still drawing 6.5 or 8.6 watts depending on which meter you read. So I'm going to let it go a little longer. So to get to the 100% mark, it took 112 watt hours. Alright, it's at 100%, and it's basically just drawing only enough power to run the screen, because this thing goes down when I turn the screen off. And it took 114 watt hours to fill this guy completely up. So that seems pretty consistent with a 99 watt hour capacity and the inefficiency losses through charging. I've been very impressed with this guy. So it's delivering about 80 watt hours out of the USB ports. It takes about 114 watt hours to charge it, so it's very consistent with the 99 watt hour capacity battery. It has a nice display. It'll tell you for each of the ports, the power going in and out. You can double tap to switch between voltage and watts. I like the fact there's this little notch there and the nub on this battery compartment cover, and so it snaps in there and it will hold itself in place. So this guy has the 2 USB-C ports, one that's in out, one that's out only, the USB-A port, and then the 12 volt and 8 volt barrel connectors, in addition to the DTap port on the side here, and then your standard kind of V-mount battery connections on the bottom there. So the Pro version here offers, in above and beyond the regular version, the extra USB-C port. That's really, as far as I've found, the only real benefit is that extra USB-C port, the battery cover here with that little notch that holds it out of the way. It's a metal case instead of a plastic case, but really, unless you need that extra USB-C port, I think the non-Pro version is just as good as this guy.